students. Good day, wonderful students of Sleek Angels International School. This is your teacher, Miss Constance, Onwunna. Today, I'll be taking the SS3 students on chemistry. We'll be looking at past wire questions. So you're expected to know exactly what you're supposed to do when you come across any question like this in WAEC, regardless of the uncertainty of the exam or the date of the exam. I would like to encourage you not to relent. You should keep studying and also follow us as we send videos of virtual classes to you in order for you to keep abreast of your academics. All right? Quickly, let us go into what we have today. Like I told you, we're looking at past WAEC questions. I've been able to draft out some questions for you, and then I will teach you how to answer those questions when you meet them in, or similar questions in your exams. And also I will teach you to know exactly what you're supposed to do, not just answering, or what WAEC is expecting you to do when you come across questions like this. Okay, so the first question is, classify the following triazocarbonate 4 compounds as soluble or insoluble in water. I'll take that again. Classify the following triazocarbonate 4 compounds as soluble or insoluble in water. So you have 4 of them here. You have sodium carbonate, potassium carbonate, zinc carbonate, and ammonium chloride. So we're going to classify these compounds based on their solubility in water. Okay, so quickly I'll just write answers. Now this is what you're expected to do, or this is the best way to answer this question. Don't just put something like this and then you write soluble or insoluble. No. Now for you to get more mark, or for your work to be very neat, or for them to know that you know exactly what you're doing, what you should do when you see a question like this is to make a table. First, okay, make 2 columns. So you're having this and this. Okay, so you make something like this. You write compound here, and then here you write solubility in water. Okay, so you write the first one, that's sodium carbonate. Second one is potassium carbonate. We have zinc carbonate, and then we have ammonium chloride. Alright, so I'm going to just demonstrate that and then give you reasons why some of them are soluble and some of them are insoluble. So I have here the compounds, the triazocarbonate compound. So this is sodium carbonate, the second one is potassium carbonate, and then you have zinc carbonate and ammonium chloride. Okay, so I'm going to just demonstrate that so you know, you see for yourself which of them is soluble in water or insoluble in water. So I'm going to just open this now. So this is sodium carbonate. This is the first compound. What do you do? All you need to do is just add water to this and then observe if it will dissolve in water or not. Okay, so I'm going to just add, this is our water, so just add a little and then you shake. Okay, this is what you do, and then you look through and see if it dissolved in water or not. From here, if you look very well, you will see that the particle dissolved in water. You can't find any of those particles when we started. So it means that this sample or this compound is soluble in water. So you write sodium carbonate, you write soluble. This is the best way to answer it. Come across it. Now the next one, quickly, potassium carbonate. This is a salt actually. So this is like all of them are salt. So we add water. Add water to this. Okay, the same amount. This one is so fast. Okay, if you can see, you're having a clear solution. Wow, this one was so fast. So what can you say? This is soluble in water. So the second one, soluble in water, we write potassium carbonate, soluble in water. The next one is zinc carbonate. The same thing, same process. So we add water. Just observe. Okay. Now, this is it. Shake. Shake very well. Shake very well. Okay. Now you observe. Look at the bottom. The solution is not clear. Look at it very well. Now if you look at the bottom, you see some particles of zinc carbonate. Now because they are left over zinc carbonate here, we say this compound is insoluble in water. Look at it again. If you let it lie for some time, it will begin to form form back the zinc carbonate. If you can see very well, showing down here. Alright. So this compound is insoluble in water. So zinc carbonate is insoluble. The last one, which is ammonium chloride. So we do the same thing. We add water and observe. Add water. Wow, this one is also very fast. Started with white salt. This is what we have at the end. Dissolved. Okay, so this is soluble in water. Ammonium chloride is soluble in water. You right there, soluble in water. Okay, so from these we have seen that 3 of them are soluble. 3 of them are soluble, while just zinc carbonate is insoluble in water. Okay, now the reason why zinc carbonate is insoluble in water is because when you add water or when you dissolve zinc carbonate in water, it does not form ions like the zinc ion and carbonate ion. It does not form ions. Okay, and another point I want you to note is that should you come across any of them in WIEC to any triazocarbonate compounds, almost all of the triazocarbonate compounds are insoluble in water. Take note, almost all of them are insoluble in water except the alkali metals. Of course, the alkali metals are the group 1 metals. So if you look at this, sodium and potassium, they are alkali metals, they are group 1 metals, so they will be soluble in water. And then ammonium too is also soluble in water. It means that all alkali metals are soluble in water. Ammonium or ammonia is also soluble in water. Then any other triazocarbonate compound you come across, they are all insoluble in water. So zinc carbonate is not an alkali metal, therefore it is insoluble in water. Okay? Alright, so that is for question number 1. We've been able to classify them based on their solubility in water. Now let us go into the second question. Second question is iron reacts with H2SO4, that's sulfuric acid, according to the equation. So this is the equation. You have iron reacting with sulfuric acid to form iron sulfate and hydrogen gas. Alright, of course you know how this iron sulfate will be formed. These will react with this to form this, and then hydrogen will be liberated from the reaction. Okay, calculate the mass of iron sulfate that will be produced by 0.5 mole of iron. Now, these are the individual masses of the elements. I'll take that again. Iron reacts with H2SO4 according to the equation. This is the equation. Calculate the mass of iron sulfate that will be produced by 0.5 mole of iron. Okay, now so we are going to write solution because we are solving. Now the first thing you will do is to write the equation of the reaction. Bring it down. So you write the equation of the reaction here. So the same thing. I'm just bringing down the equation. Looking at it, the equation is balanced, so there's no need adding anything, okay? Now, the next thing you will do is to equate the elements or compound that are the same or what you're looking for. Now, if you look at the question very well, you're asked to calculate the mass of iron sulfate against 0.5 mole of iron. It then means that you're working with only iron and iron sulfate. So the other parts of the equation are not needed. I've taught you this, it's just a revision for you. So since we are working with iron and iron sulfate, we equate them in terms of ratio, okay? So you say 1 mole of iron produces, I'm teaching you how to answer it, should you come across it in white. 1 mole of iron, okay, let me just write it. 1 mole of iron produces how many moles of iron sulfate? 1 mole. Produces 1 mole of iron sulfate. Beautiful. Okay, we want to look for the mass, but we need to get the mole of iron sulfate before we calculate the mass. So if 1 mole of iron produces 1 mole of iron sulfate, therefore 0.5 mole of iron will produce 0.5 mole of iron sulfate. Okay? It means we have gotten the mole of iron sulfate as 0.5. I'm just going to underline that so that you will know exactly what we did. So we got the mole of iron sulfate from the mole of iron, okay? Now, the next thing you will do, because we are looking for mass, there is a formula that connects mass, molar mass, and mole. Let me just write the formula to remind you. Amount in mole is equal to mass all over molar mass. Okay? Now what you will do is to get the molar mass of iron sulfate. So you come here, you write molar mass of iron sulfate will be equal to, iron is 56, so we say 56 plus sulfur is 32 plus, then oxygen was not given, of course you know oxygen is equals to 16, so oxygen is 16, then you have 4, if now is 16 multiplied by 4, okay, so you have 56 plus 32 plus 64, alright, so I'm going to just add that together to get, I'm going to add that together, get my calculator, so have 56 plus 32 plus 64, okay, so the answer is 152, so 152 gram per mole, because you know that's the unit for molar mass. So this is our molar mass and this is our amount in mole. What do? We make the subject of formula. Therefore, mass is equal to amount in mole multiplied by molar mass. So you have amount in mole is 0.5. 0.5 multiplied by molar mass, which is 152. Okay. So I'm going to just do that. 152, that's our answer, multiplied by 0.15. You have the mass as 76 grams. Okay, so just use red. So this is our answer, 76 grams. You can now write 76 grams of iron sulfate. Now this is how this question is. This is how you're supposed to do it in YX. Should you come across anything related to this, just state it this format, and then you're sure of your complete marks. Okay, do not by cut or try to reduce because you want to write fast. Make sure you state all the points that are needed. Now you start from equating to ratio, and then you get the mole. From the mole you state the formula that connects mass, mole and molar mass. When you state that, you get the molar mass. You tell them you're calculating for the molar mass of that compound, and then when you get the molar mass of the compound, the next thing, you make this subject of formula, and then you write it for them so that they will know that you didn't just copy, you know what you're doing, and then you write the value and get your answer. Okay, so this is exactly how you're to answer it should you come across it in YA. Okay, let's look at question number 3. Calculate the volume of carbon 4 oxide, that's CO2, produced when 5.3 grams of sodium carbonate reacted with SS nitric acid, that's HNO3. Now the equation of the reaction is this: sodium carbonate plus nitric acid give you sodium nitrate, then carbon 4 oxide will be degraded, and then water. Now you're given the individual masses: hydrogen, carbon, nitrogen, and sodium, and then 1 mole of a gas occupies 22.4 dnq. Okay, this is very important because you'll be using it to calculate. Now, from what the last one, I told you that the first thing you will do is to write down the equation of the reaction. So let's write it down now. Bring it down. Sodium carbonate plus nitric acid plus 2, then use sodium nitrate, sodium nitrate plus CO2, and then water. Okay, then there's 2 here. Now, having written down the equation of the reaction, the next thing you will do is to look at the question again and know what and what is given, and then you will know what you're supposed to use. So from here, you're asked to calculate the volume of CO3. So I'm going to just underline that. Now we're calculating the volume of CO2 produced when 5.3 grams of sodium carbonate. It then means we are interested in sodium carbonate and carbon 4 oxide. That's all. The other compounds are not necessary, okay? Because we are giving the amount of this as against the volume of this. Now, the first thing you will do again, or the next thing you will do, is to equate them based on ratio, okay? So, from this reaction, you see that 1 mole of sodium carbonate produce 1 mole of CO2. Now, from knowledge, you know that 1 mole of a compound that is in solid or liquid state is usually the molar mass of that compound. So it means we'll get the molar mass of sodium carbonate. Now, how do we get the molar mass of sodium carbonate? 23 multiplied by 2 plus 12 plus 16 multiplied by 3. Okay, you just add the individual masses and then you get the molar mass. So we'll say this of sodium carbonate, you state it like this in the exam in your booklet, and then it should help the examiner who is marking to understand what you're doing. Then produce 1 1 mole of any gas, of course, CO2 from here is a gas. 1 mole of any gas, look at it, 1 mole of a gas occupies 22.4 dNq. So 1 mole of CO2 will be 22.4 dNq of what? CO2. Okay, so we get the mass of this. This is my calculator. We have 23 multiplied by 2. This is 46. 46 plus 12 plus 60 multiplied by 3 is 48. Okay, so let's just do total. 46 plus 12 plus 48, that's 106. So we have 106 gram per mole of sodium carbonate produce 22.4 dNq of CO2. That still retains that because it's 1 mole. If we have 2 here, it will now be 22.4 multiplied by 2. But because it's just 1, so it's 22.4 dNq. Now this is the gram of sodium carbonate, and they are asking, the question is, calculate the volume of this produced when 5.3 gram of sodium carbonate. So you say, therefore, 5.3 gram of sodium carbonate will produce SDNQ of CO2. SDNQ, because that's what we are looking for. The next thing is to multiply then SDNQ, which is of CO2, will be equal to this multiplied by this. So you have 5.3 multiplied by 22.4 all over 106. Okay, so I'll use my calculator for that. So you have 5.3 multiplied by 22.4 gave us 118 point. So you have 118.72 all over 106. Now say answer, divide by 106. 106, that gave us, so SDNQ of CO2 is equal to 1.12 dNq. I'm gonna just underline that. So this is our answer, 1.12 dNq of this. That is the volume of CO2 that will be produced. Alright? So this is exactly how you would state or write it in your exam should you come across any question like this. Or similar question, yeah? Might not be exactly